Have you ever wished you could see a supernova up close? While we don't quite expect that in 2024, you will have a chance to see what is arguably the next best thing, namely the explosion of the Blaze star. And surprisingly, it just keeps exploding. Back in May 1866, on a partly cloudy spring night in the west of Ireland, amateur astronomer John Birmingham was on his way home in the dark just before midnight. His pace slowed occasionally so that he could look up at the stars. With a sharp eye, he scanned the night sky for familiar constellations like he had done countless times before. As his eyes reached the Northern Crown, he stopped, stunned. There was a new, bright star in this familiar constellation. He had observed a recurring nova in the binary star T Coronae Borealis, nicknamed the Blaze star, an explosive astronomical event that happens once in a lifetime. This event would help to revolutionize our understanding of nova events and shape the field of stellar astronomy in the following decades. And for those of us alive in 2024, we will have the unique opportunity to experience the same recurring nova explosion that captured Birmingham's fascination more than 150 years ago on that cool spring night in Ireland. And you won't even need a telescope or any fancy equipment to see it. Why is it going to happen again? And when will it happen? I'm Alex McColgan and you're watching Astrum. Join me as we prepare to observe this extraordinary stellar event. The nickname Blaze star may be a bit misleading, as it's actually a binary system of two stars locked in orbit with each other. And it's the relationship between these two stars that causes the nova explosion to occur every 80 years or so. In fact, it's estimated that about 50% of the stars we see are not solitary, but multiple star systems. Both of the stars in the binary Blaze star system started out as average-sized stars, similar to our Sun, but each one is at a very different stage in their life cycle. Small and mid-sized stars generally follow the same evolutionary path as our own Sun. At 4.6 billion years old, our Sun is considered a middle-aged, average-sized star. In 5 billion years, it will run out of hydrogen fuel and begin to fuse heavier elements, expanding into a red giant that may become so large that it engulfs Mercury, Venus, and possibly even Earth. As the red giant uses up its remaining fuel sometime between 5 to 10 billion years from now, it will eventually cast off its outer shell, creating a nebula of gases surrounding a white dwarf, the extremely dense and small core remnants of the once giant star. White dwarfs are often called dead stars, as they have no more fuel and will spend the next 10 trillion years cooling off until they no longer emit heat or light. Both of the binary stars in the Blaze star system are average-sized stars on the same trajectory, but they are further along in their stellar evolution than our Sun. In fact, this is the very reason for the recurring nova we will be able to witness in 2024. It all comes down to the relationship between these two stars, one a red giant and the other a white dwarf. As the red giant heats up and its outer shell expands, it is continually stripped of hydrogen by the immense gravitational pull of its neighboring white dwarf. Over time, the white dwarf collects this material on its surface, kind of like a cosmic vacuum cleaner, causing a buildup of pressure and heat. Eventually, this buildup becomes too much and causes a thermonuclear explosion that blasts away all of that built-up material. Picture the white dwarf like a party popper. You keep pulling the string tighter and tighter, adding tension. Finally, you pull too hard and it pops, sending confetti flying everywhere. This is kind of like the pressure and heat that builds up on the Blaze star's white dwarf until it finally reaches its limit. The result? A nova explosion so powerful it can make the Blaze star appear 1,500 times brighter than usual about once every 80 years. As seen from Earth, 3,000 light years away. So how is this different from the more famous supernovas? While the Blaze star does experience a massive explosion with each nova, referred to as a classic nova, it does not destroy the white dwarf where it occurs. Instead, it simply blasts away the material collected from its neighboring star every now and then when pressure and heat become too much, and it happens to be close enough to us that we will experience a significant change in its brightness from Earth. On the other hand, for a solitary star to destroy itself at the end of its life by exploding in a grandiose supernova that can be millions of times brighter than the blaze nova, it has to start out with more than 8 times the mass of our Sun, much more massive than those in the blaze star. The closest star on a path toward a supernova explosion in the near future is the red supergiant Betelgeuse, a star that often appears as one of the 10 brightest in our night sky, despite being 640 light years away. And by the near future, I mean in cosmic perspective. So don't worry, scientists don't expect this star to go supernova for tens of thousands of years. In cosmic terms, that's just around the corner. In human terms, not so much. But just for a moment, imagine the awe-inspiring view that anyone on Earth would witness as Betelgeuse explodes in a supernova. After the initial explosion, the star would become as bright as a full moon and remain visible during the day. What a sight that would be. However, while extraordinarily rare, Betelgeuse won't be the first time humanity has witnessed a supernova, and the blaze star is certainly not the only nova in recent history to be visible to the naked eye. The oldest record of a supernova, now called SN 185, comes from Chinese astronomers in 185 AD, when they recorded what was called a guest star, which appeared in the night sky for a staggering 8 months. Modern astronomers have been able to find the remnants of this explosion to confirm that it was in fact a supernova. There have only been a handful of supernovae that were visible with the naked eye in recorded history. One of the famous instances, and most recent, was in 1604, when the German astronomer Johannes Kepler documented a supernova that was so bright, people could see it during the daytime. What we will experience in 2024 is expected to be one of the brightest classic nova of this century. And just like a supernova, this is a rare and noteworthy occurrence. Classic novas that are visible to the naked eye occur relatively frequently, at least compared to supernovae, but despite these classic novae being visible in our night sky about once every year or two, they are rarely bright enough for the untrained or unaided eye to spot. The blaze star, on the other hand, is expected to be one of the brightest classic nova to appear in our night sky in nearly 50 years. In astronomy, a star's brightness as seen from Earth can be measured on a scale of apparent magnitude. The smaller the magnitude, the brighter the star. So a star with a magnitude of 0 is brighter than a star with a magnitude of 1. A star with a magnitude of 1 is brighter than a star with a magnitude of 2, and so on. Typically, it takes an apparent magnitude of about 6.5 in order for a star or planet to be visible to the naked eye on the darkest night. For some perspective, the 7 stars in the Ursa Major constellation, also known as the Big Dipper, have apparent magnitudes ranging from the dimmest at 4.8 to the brightest at a magnitude of 1.7. The brightest star in the night sky is Sirius, with a magnitude of negative 1.44, and the daytime sun has a magnitude of negative 26.5. Yes, the apparent magnitude scale goes into the negatives. The magnitude of the blaze star is usually 10 and not visible to the naked eye from Earth. But during the nova explosion every 80 years, this star peaks at a magnitude between 3 and 2, making it appear from seemingly nowhere to become one of the brightest stars in the sky. Interestingly, the term nova comes from a Latin word meaning new, and I'm sure that before telescopes, it must have been a shock to see a new star appear out of nowhere. More recently, there was Nova Centauri 2013, which surprised astronomers by being one of the brightest in over a century, with a peak magnitude of 3.3. The last time the blaze star nova exploded in 1946, it reached a magnitude of 3. But this year's appearance of the blaze star is expected to be even brighter than that, possibly reaching a peak magnitude of 2, which would rival that of Polaris, the North Star, which has a magnitude of 1.97. But this stellar show won't last long. Once it erupts with the nova explosion, the blaze star may only be visible to the naked eye for a few days or a week before it fades back into the darkness. There is no exact date when it will happen, but scientists predict it may happen any day now going into the second half of 2024. Be sure to keep an eye on the news and the sky to find out when the nova explosion begins. To find the blaze star in the night sky, look for the two neighboring constellations of Hercules and the kite-shaped Boötes. The blaze star will be located in a small semicircle shaped constellation called the Northern Crown, located between these two larger constellations. If you trace the Northern Crown starting from the Boötes constellation and ending on the side closest to Hercules, the blaze star should appear just below the last star of the Northern Crown. And if you have access to a powerful amateur telescope or can visit a local observatory, you may even be able to spot this binary star before the nova begins to be able to truly compare. These novae remind us that even stars, which can seem eternal and unchanging, have astonishing life cycles that can include drastic changes and dramatic explosions, like a cosmic fireworks show, rare and awesome. Each nova provides a unique opportunity for astronomers to gather data that will help to refine our understanding of stellar evolution, binary star systems, and explosive stellar phenomena. This nova will be one of the most exciting astronomical events we will get to see in our lifetime. So keep an eye on the night sky and maybe feel just that little bit luckier to be alive and to be able to experience this here on Earth. Have you ever seen a nova with the naked eye before? Do you have any special plans in place for when the blaze star nova begins? Until next time, keep looking up, stay curious, and let me know your thoughts in the comments below. If you've been watching my videos for long, then it's likely space is as much of a passion for you as it is for me. Space is wondrous, filled with awesome galaxy clusters, incredible planets, comets with tails cascading behind them. It's cool to watch videos about them, but do you ever get the urge to see all these things for yourself with your own eyes, or even make some discoveries of your own? If you want to do that, you'll need a good telescope. So, in a match that for this channel just makes perfect sense, the sponsor of today's video is Unistellar's Odyssey Pro telescope. There are three things about this telescope that made me really excited to get my hands on it. First, it's the only telescope on the market that's just as good at imaging deep space objects as close ones. Go from looking through its Nikon eyepiece at our moon to a whirlpool galaxy, and send the images straight to your phone or tablet. Secondly, it's a dream to set up. It's portable, takes care of focusing itself, and is very simple to use, meaning even beginners can explore the universe in minutes. Just look at these images I was able to take with just a 4-minute exposure. Finally, Unistellar is part of NASA citizen science programs, meaning that when you use this telescope, you can passively or actively enroll in observation missions to help NASA track exoplanets or record asteroids like during the DART mission, furthering human knowledge as you stargaze. I love that. Scan my QR code or follow the link in the description below to get started on your own stargazing journey. And if you use my promo code Astrum1024 at checkout, you can get 20% off your purchase. Go check it out. Thanks for watching. I really want to give a huge thank you to our astronauts on Patreon. It's really becoming a thriving community, and I've loved reading all your messages and comments over there. If you'd like to join in, then you can visit the link in the description to become an astronaut and bring the channel more stability than the algorithm. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Once again, a huge thank you from myself and the whole Astrum team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.